Okay. What does this U mean? What does the U mean? Union. Does that mean all together or overlap? All together. So how do I find A union B? What do I do with those numbers in set A and those numbers in set B? Just put them all together, right? List all of the numbers. You're not listing intervals, though. This is not saying all the numbers between -1 and 2, right? Like the intervals, this is just saying -1, comma, 2, comma, right? So we're just saying every single number in the sets, right? So -1 is in set A, so it needs to go in there. 2 is in set B, so it needs to go in there. It's also in A, but we don't need to write it twice. 4 is in set B, so it needs to be in this answer. 5, 6, 7, and 10. Just everything all together, right? You're just listing out all of the numbers all together. What does the upside down U mean? Intersection, overlap, right? So now you're not looking at all of them all together, but only the ones they have in common. So which numbers do they have in common? What is a number that is in both sets? 2 is in both sets. 6 is in both sets. Is that it? So those are the only numbers that are in the intersection, right? The intersection is just those two numbers. And you're putting the squiggly brackets because we're just listing the numbers, right? This is not an interval of values. Okay, for number 2, they give us inequality notation. This is x is bigger than -5 and less than or equal to 3. So we need to start at -5 on the graph, go to 3. Do I need an open parentheses or a closed bracket at -5? Open, because it's just less than. There's no line underneath. So you can, if you want to do open circles too, that's fine. It's the same as open brackets. So we need an open parentheses at -5 because it's not greater than or equal to. It's just greater than. And then should it be a closed bracket or an open parentheses at 3? Closed bracket. And then everything in between, right? Because it's x is between 3 and -5. So now go ahead and write what that is in interval notation if you haven't done it already. That's easy. Now that you've graphed it, writing it in interval notation right here is a piece of cake because you've pretty much done it already on the graph. Where does my interval need to start? What number? -5, and it needs to go to what? 3. And then I've already done the brackets, right? So I literally have done everything. -5 to 3. Because I already put the brackets on the graph. So the next one is from 3 to infinity and from 2 to -infinity. So from 3, it has an open bracket already, all the way to infinity. And then from 2, closed bracket or closed circle, all the way to -infinity. It's telling you exactly how to graph it, right? You really don't have to think too hard. It kind of tells you everything. 3 to infinity, 2 to -infinity. Now, this inequality notation, I think, is what messed most people up on the Unit 2 test. So this is really important, this one right here. When there are two separate things, okay, we have to separate them. They can't just be all together. They have to be separate. So how do I describe these numbers right here with the inequality notation? What do I do to say this? These are all the numbers bigger than 2 or less than 2? Less than? Is it going to be an equal to, or is it going to be just a less than? Equal to, right? So go ahead and write that down, and write down what the inequality for this part is. And I'm going to come check it. So write it down. No phones allowed today. You're getting too distracted. Too important. So they have to be separate. Make sure they're separate. You can use the word or. You can use the symbol, the union symbol. So describe that with an inequality. All those numbers there. Nope, and because you need to be using an x, right? You got to say x is less than, greater than, x is equal to, right? That's what inequality notation is. Yes. You got to keep them separate because they're separate on the graph. Yeah, that works. Okay, so these first numbers here from negative infinity to 2, this is all the numbers that are less than or equal to 2, right? Everything from 2 and below. So x is less than or equal to 2. You need to have that. Then we have all the numbers bigger than 3. So we also need to have x is greater than 3. Some of you use the infinity, and you can do that as well. You don't have to, but that's fine if you did. Okay? And you can use or you can use the union symbol, but you have to have them separate. And they have to mean that. Okay? All right, go ahead and draw your interval from this one. What does that look like if you haven't done that already? Starts at -1, open because there's an open circle, goes to positive infinity. So now write it with an inequality notation. X is what with -1? Less than, greater than, less than or equal to, greater than or equal to. All of these numbers here are bigger than -1, right? So x is greater than -1. Any questions about those? All right, let's talk exponents, okay? Here we're dividing. What do we do when we're dividing? What do you do with the exponents when you're dividing? Subtract, right? What do you do when you're multiplying? What do you do with the exponents? Add, right? So dividing is subtraction, multiplying is adding. Do I subtract 9 and 6 though? Are 9 and 6 exponents? No, remember that rule is for exponents. 9 and 6 are not exponents. So what do I do with 9 and 6? I just divide, right? Those are just numbers being divided, right? Does 9 divide by 6 into a nice number? No. So what do? I just simplify my fraction then. Go ahead and simplify that fraction. It's going to become 3/2 because we can divide both 9 and 6 by 3. That's my leading coefficient. And then I want you to go ahead and write down what the x exponent needs to be and the y exponent. What are you doing with the exponents? Adding, subtracting, multiplying, dividing. Subtracting. Subtract your exponents and write them down. Manon, what'd you get for the x exponent? 3. 5 minus 3 was 3. Ian, what'd you get for the y exponent?
7.
Positive 7?
Oh.
Should be -7. Yep, -7. Because 2 minus 9 is -7. Okay? We're subtracting. Now, can I leave my answer like that, though? No, I'm not allowed to have negative exponents. What do I do to get rid of the negative exponent? Move it, right, to the denominator. These are automatically in the numerator. Whenever you do this division stuff, you're automatically putting them in the numerator, okay? Do I need to move the x and the y to the denominator? Which is the only one with the negative exponent, the x or the y? The y, right? So I just moved the y to the denominator. So you're going to have the x cubed is going to stay with the 3 in the numerator. And the y is going to move to the denominator with the 2 and become positive. For number 6, we have two things going on. We have this 3 exponent and we're multiplying, right? This means multiply. Which one of those do I do first? Exponents or multiply? Exponents first, right? PEMDAS, good old PEMDAS, exponents first. So we need to do this 3 to these things. So we said division was subtracting, multiplying was adding exponents. What do I do if I have something like, x to the 5th to the 2nd power? What do I do with those numbers right there? That's when I multiply those numbers, right? So when you're raising something to a power, that's when you multiply. So we're gonna do this exponent first. So go ahead and do that first, and just write down what the x exponent is, the y, and the z for that first part. Just doing the 3 first. Aurora, what'd you get for your x exponent, just for this part here? What'd you say? 12? X is 12, 4 times 3 is 12. Mia, what did you get for your y exponent right here? Mia, did you hear me? What'd you get for your y exponent right here? Did you do the y's? Go ahead and do that now. Samantha, how about you? What'd you get for the y?
I don't know if it's supposed to be negative, but I got 9.
Yeah, negative 9. Because it's negative 3 times 3. Great question. And then the z should be 6. 2 times 3. Then we can do our multiplication. And what did we say we're going to do with the exponents when we multiply? Add. What exponent is with this y here, though? What little invisible exponent is with the y? 1, right? Okay, go ahead and multiply those together to get your final answer, and then make sure your final answer has no negatives in it. So you need to multiply the x's together and the y's together and the z's together. And when you do that, what are you going to do with the exponents? Add, subtract, multiply, or divide. So now we're multiplying, right? So what did we just say we're going to do when we multiply these together? What are you going to do with the x exponents? Add, subtract, multiply, or divide. Add. So when you're multiplying, you're adding the exponents. When you divide, you subtract, right? So here, take the x. So if you have x squared and x to the 12th, this will become x to the what then? Yep, so try that with the y's and the z's. You multiply. We should be adding, right? Because when you're multiplying, so the only time that you multiply is when they're right next to each other like that, right? Because this was raised to the exponent. So when you divide, you subtract. When you multiply, you add the exponents. And then when you raise it to the extra power, that's when you multiply. Okay, so our x should be 14, right? Because we add the exponents. When we multiply, we add exponents. Dividing, subtract exponents. Multiplying, add exponents. The only time you multiply is when they're right next to each other, right? When you're raising it to another power. So x to the 14th, y to the negative 8th, and z to the 3rd. But I can't leave my answer like that with a negative exponent, so I need to move which one to the bottom, x, y, or z? Just the y. So we are going to have x to the 14th, z to the 3rd, and then move the y to the denominator to make it have a positive exponent. Any questions about that one? Okay, take a second and pause and circle any questions that you know you need to go do some more practice on with 1 through 6. Reflect on 1 through 6. Circle any more that you know you need to go do some more practice on. Okay, simplifying radical expressions. The first thing that we do is we separate the numbers and the letters. You can do it with the factor tree if you want. That's just not how I prefer to do it, and that's fine if that works for you. We're going to separate the letters and the numbers. Do I need to separate the square root of 36 anymore? No, what's the square root of 36? 6. That's already a perfect square, so I don't want to touch that. I need to leave that alone. It's already a perfect square. But I do need to separate the x to the 7th because every time I have a square root of x squared, that's a good thing, right? Because the square root of x squared is just x. So I want to separate this into as many x squareds as I can. So square root of x squared, that's 4, right? We have 7 total. So that's 4. I get another one, that's 6. And then I'm left with one more. So I'm going to have just a square root of x at the end. If I'm just taking the x to the 7th and I'm breaking it up into as many x squareds as I can. Then the square root of 36 becomes 6. And what does the square root of x squared become? Just a plain old x. So you're going to have times x. Each of those square root of x squareds becomes x. Does the square root of x become x though? No, can I do the square root of x? No, so it stays underneath. And then if I simplify that, that should be 6x to what power? To the third. We've got x times x times x. Yeah.
Could you have also done just like x to the 6 times x and then...
Yeah, as long as you realize that x to the 6th is x to the 3rd. That's fine. Yeah. Everyone has different ways of doing it. I just try to break it down to kind of consistency, but whatever way works for you. Okay, so for number 8, the first thing we're going to start by doing is separating the number and the letters. But now 20 is not a square root, so you're going to have to find the perfect square that divides 20 and break that up into 2 numbers. So go ahead and try number 8. Yes. Yep. Okay, so the square root of 20, perfect square that divides that is 4. So we're going to break this up in 4 times 5 is 20. Square root of 4 times square root of 5. I can break up x to the 4th into x squared and x squared because there was 4 x's. And then y cubed can be broken up into 1 y squared, and then 1 has to stay by itself. Square root of 4 is going to become 2. I cannot do the square root of 5, so that stays. Square root of x squared becomes x. Square root of x squared becomes x. Square root of y squared becomes y. And I can't do anything to the square root of y. So then all these things that are not under the radical are going to go together in the front, right? So we're going to have a 2, an x what? Squared, since it's x times x, a y, and then left underneath will be your 5 and your y. Okay, for number 9, remember we can only add radicals when they have the same radical, right? This one's radical 5, this one's radical 45, this one's radical 20, right? So they're all different radicals, so we cannot add them together yet. So we need to simplify them first, and then we can add them together, okay? So for 2 radical 5, this one's already simplified. We don't need to simplify that anymore. But let's simplify square root of 45 together. Biggest perfect square that divides 45 is 9. So this is going to be the square root of 9 times the square root of 5. 9 times 5 is 45. Square root of 9 becomes what? 3. Can we do the square root of 5? Nope, so it stays underneath. So 2 square root of 5 just stayed the same. We didn't simplify that. We now just took the square root of 45 and we turned it into 3 radical 5. But now we need to simplify to radical 20. Biggest perfect square that divides 20 is 4. So we're going to break this up into 2, radical 4, radical 5. So go ahead and finish that one. So radical 4 becomes 2. We can't do anything to the 5. But don't forget, you had this 2 out in front, right? This is why I wrote it down here. Because now what do I have to do with that 2 and the 2 we got from the 4? We have to multiply them together, right? Don't add them together. You're multiplying because this is 2 times radical 20, right? So when 20 becomes 2 radical 5, we have to multiply by that 2 to get 4 radical 5. Now those are all radical 5s, so we can add them together. So 2 radical 5 plus 3 radical 5, we'll start in the parentheses because that's what those mean, will be 5 radical 5 plus 4 radical 5 will be 9 radical 5. Any questions about that one? I know it's been a while, so. Okay, the next one, domain and range. This is nice and easy. The domain is always the x values or the y values? The x. So here we just list all the x values. So the x values are -2, 0, 2, and 5. And the y values are -5, -3, 6, and 10. Increasing, decreasing, constant. Remember, you're going to start on the left side of your function, trace along, ask yourself when you're going down, that's decreasing. When you're up, that's increasing, right? If you're staying the same, that's constant. When we list our intervals, do we use x values or y values? X values. So go ahead and do the increasing and decreasing. Do we have to put the brackets on? The only time with increasing and decreasing go to bracket is if it's at the end and it's closed. If it's changing from increasing to decreasing, it has to be open. Parentheses. Open because it's changing from increasing. The only time it's increasing, you can close it is at the end. function doing right now? Is it decreasing or increasing? Okay, and where does it start decreasing? X values, X values. But does it really? Because what does that arrow mean? It keeps going, right? So negative infinity. This is increasing. You said increasing. And then where does it stop decreasing at? And so look at it with the X value, X value, X value. No, they can only be brackets if it's at the end. Like if it is at the end, yeah. Because if it has to change from increasing to decreasing, it has to be open. It's not increasing and it's not decreasing.
It can't be a bracket, don't use infinity, right?
Yes. Correct. You are correct. Okay, at the beginning here, my graph is decreasing. It's going down. But there is no starting X value, right? It's going to start doing that all the way down there at negative infinity. So it's decreasing from negative infinity. And then it stops decreasing right here. But remember, you got to use the X value. That X value is negative 4. Then it starts going up again. Up from negative 4 X value all the way to this point at the top. And it stops increasing right there, and that X value is 0. So it's going to be increasing from negative 4 to 0. Those all have to be open brackets because it's changing from increasing to decreasing. Then it starts decreasing again, right, at 0, until we get to 4. The X value of 4. So it's going to be decreasing from 0 to 4. And we usually use a union there. And then it starts to increase again from 4 all the way forever to infinity. The only time with increasing and decreasing that you can have closed brackets is at the very ends.
At that very end, it has to be a dark
But
circle.
yes, exactly. If it was an open circle, it would still be an open bracket. If it was a closed circle, it would still be a closed bracket. Since we're going to infinity, it has to be open. Any questions about that one? Number 14 is not very good for this graph. I copied it from the other question on the other paper. It's a much nicer question on the other paper, so we'll skip that one. Are there any intervals where this function is constant? No. And then go ahead and do the domain and range on your own. So the domain, remember, is which ones? The X values or the Y values? X. So look at where's the starting X value and where's the ending X value. For the range, look at where's the very first Y value and where's the very last Y value. The one on here is a much nicer. So you're looking at where the Y value is in negative 2. Over here is a better question. This is not a good question on this graph. It's better than this one. So yeah, so at negative 2 is right here, right? So it would be here, 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 here. All of them X values. That's the Y value because it's the function. Constant. Remember where it stays the same?
Oh.
Look at the other paper.
Yeah.
The other one that we have has a constant example.
And you said it's not working.
Yeah, that's not good for this graph. I copy and pasted it
What
from
would
the
you
other.
make?
Because I copy and pasted it from the other one. So if you do the other worksheet, it's a good graph.
Oh.
Okay, so for the domain, can I say that it starts at negative 10? Because that's where this graph starts. Should I say it starts at negative 10?
No.
No, this keeps going forever that way, right? So the X values are not going to start at negative 10. This graph goes forever. That's what the arrow means, right? So it's going to be from negative infinity. And then is there a last X value here where my function ends? No, it keeps going this way, right? So it's going to go to positive infinity. Because the function continues going, there's no first X value and there's no last X value. But what about the Y values? Is there a Y value where my function starts at? Does my function exist down here at negative 9? So where does it start? -4, and then it keeps going up. Does it stop at 5? No, it keeps going, right? Past beyond 5, all the way up to infinity. So from -4, and it does hit -4, so that needs to be included, all the way to infinity. I highly recommend doing this because I think everyone had little issues on the other review worksheet. Like I said, a lot of them I did just a similar question on the next one. And the other one does have some examples of constant intervals. So I highly recommend everyone circling 11, 12, 13, 15, and 16 to do on the other worksheet. But take a minute to think about 7 through 16 and circle any that you want to do more practice on. Okay, we are actually going to skip over and come back to 17 through 23 if we have time, because those were all like the unit that we just did, okay? So the answers to this will be posted if you want to do those as extra practice, and there are also problems just like this on the other worksheet that has a video posted. So you still have lots of opportunities to practice that. I definitely recommend doing them, but since we just did that, it's better to go back and do the older stuff first to refresh our brains. So we are going to do the table, though, because people were having trouble with the table. So let's start with the tables. We're going to start with question number 24. So 24, this is a composition. So this is f of g of 6. So f of g of 6, write down what it means. And then I need to start with g of 6, right? So remember, I go to the x value of 6, and I look at where's g. It's down here at 3, right? So g of 6 is going to be 3. Are there any questions about how I got that from the table? That is what I'm most concerned about right now, that g of 6 is 3. So you're going to the x value of 6, and you look at what's g. It's 3. Then what do I do with that 3? F of 3, right? I just found g of 6 was 3, so now I take that and I plug it into f. I'm going to look at my table, find the x value of 3, and ask myself, what is f? Well, it's 4. So that's your final answer. I want you to try 25, 26, and 27 on your own, but remember with 26 and 27 to write down what they mean, because this means f at 6 and g at 6. It's not a composition for 26 and 7. Let's go ahead and try each of those. 25, you should have gotten 3. We start by plugging 7 into F. If we plug 7 into F, we should get out 6. Then we take that 6 and plug it into G because it's a composition. So we plug that 6 into G, we look at X equals 6, and G is going to be 3. Any questions on 25? 26 and 27 are a little bit less hard on the brain. You're just doing F at 6 and G at 6. So you're literally going to go to 6 on the graph and say, what's F? Well, it's 5. What's G? It's 3. And then we're adding those together. Right? And then for 27, we're doing G at 7 and F at 7. It's 4 and 6. And then subtracting to get -2. Any questions on those? All right, let's bring it way back now. Solving equations. I want you to try it. Try to solve this equation and simplify. 28, you're solving because there's an equal sign. 29, you're just simplifying. If you don't remember where to start, ask. Those are the ones you ask me questions about, and we just did one similar, so I can practice it. Yes, the brackets. But you're going to do, so -6 close bracket all the way to -3 close bracket. No, you're going to list the interval because it's every single number in between -6 and -3, right? Even -5.5, -4, plus 6. Bracket, close bracket. Yep. Bring the whole negative there. Yes. I think so. All right, I'm going to work through 28, so check yourselves. The very first thing we should do is distribute the -2. Remember, the negative has to go with the 2. So -3x minus 2x minus 10 plus 8 is what you should have after distributing. Then we combine like terms. -3x and -2x, that's going to be -3 minus 2. So that's going to be -5x. -10 and 8 become -2. And then you can start solving, right? So distribute, simplify, solve. Now we can solve by adding 2 to both sides. Oh, I didn't mean to. Sorry. Thank you. So -5x minus 2 equals 7 is what you should have when you're done simplifying. Add 2 to both sides. And we get -5x equals 9. And then divide by -5. Any questions about that one? We've been practicing this stuff while doing other math, but it's also been a while, so you might need to go back and do some more practice of that. For 29, we're simplifying -3x plus 6x minus 12 minus 4x. Our x's are all going to combine to become -3 plus 6 will be 3 minus 4 will be -x. And then the 12 will just be by itself. So we're not solving. There's no equation there. We're just simplifying. And lastly, piecewise functions. If I'm given a piecewise function, how do I solve this problem f of negative 3? Usually I take negative 3 and I plug it in where there's an x, right? But which one do I plug it into if we're doing f of negative 3? Top, middle, or bottom? Top. Why? Because it's less than 1, right? You look at this to see, is this number in which category does it fall in? It goes into the top. So you're going to plug it into the top. Negative 3 squared is 9. Minus 2 is 7. The second one is what always throws you guys off. F of 1, which one am I going to plug it into? The bottom, the middle, or the top?
Middle.
But is there an x to plug it into?
No, it's just-
So is the answer 1? No, what is it? 8, right? It's just what that function is. And then for the last one, you're going to plug it into the bottom because 3 is greater than 1. So you're going to look at where the function negative 2. So where's the y value negative 2? Right here. So this is all right? So it's going to be negative 6 to negative 3 so it's brackets. Yeah. Just take your stuff with you since it goes up. So make sure that I definitely recommend doing the extra worksheet. Answers are online with video, right? But especially do the ones that you know, like you circled, right? Use that to help you study. Yep. Or use that for collateral.
Something expensive.
Or something that you won't please do. So it's just going to be this part right here. From negative 6 to negative 3 is closer to the bracket because it is at base. Yeah, it'll be the same thing as this one, but it's close. Because it is negative 6, it is negative 2 at this time. That makes sense. You guys look awesome, by the way. I love it. Seriously, you guys look awesome. I was like so excited when I saw someone here in my first period. I was like, yes! I've been waiting for this day. Do you guys? Yeah, I think you all look awesome. Do you guys do anything when you're all dressed up, or do you just dress up?
We have an inspection.
Okay.
We're gonna see if we can do everything.
Yeah. Let me know how it goes tomorrow.